Okay, good morning and welcome back to Calculus 2. We are looking at the problem 3b for the integral test to see whether or not this series converges. So we have 1 over natural log of n squared. We're going to see about that. So the first thing we have to do is check to see if it's continuous. Again, we have that n is greater than or equal to 2. So if I plug a 2 in here, we have natural log of 2. It's going to be a fraction, and we're going to square it. So that's going to work out. The only thing I have to worry about is if we end up with a natural log of 1, or natural log of 1 in the denominator, which will be a 0, or a natural log of 0, which will be, that's a asymptote. So we have to worry about that. So since we are starting from n is greater than 2, the 1 over n isn't going to be a problem. That's going to be continuous. The ln of n squared is going to be continuous. That's not a problem. So the next thing we have to do is check to see whether or not they are positive. 1 over n is positive. 1 over natural log of n is also going to be positive. 1 over natural log of n. We're multiplying all of these together. For n is greater than 2, this will be positive. This piece will be positive. This piece will be positive. And multiply them all together, they're all going to be positive. Okay, so we're all positive. The next thing we have to do is we have to go ahead and do a first derivative, to see whether or not that we have a decreasing function. So again, I'm going to say this is n times the natural log of n squared, all raised to the -1 power. I'm going to go ahead and change it to x's so I can take derivatives with continuous functions. So we have x ln of x, okay, and this whole piece here is going to be squared, okay, and the whole piece on the outside is -1. Okay, let's go ahead and take our derivative. We'll call that f of x. F prime of x is going to be -1 times everything on the inside, natural log of x squared, all raised to the -2 power, times, and now we have to go ahead and do the next part of this. So we have, again, the product rule. So derivative of the first is 1 times the second, that's ln of x squared, plus the first, that's x, times the derivative of ln of x squared. That's going to give me 2 ln of x raised to the first power times the inside of this piece, which is 1 over x. We have the chain rule on top of this thing. See, aren't you glad you did well in Calc 1 now? Okay, so we have equals -1. Here we have x ln x squared, all raised to the -2 power here, times, we'll make this a little bit nicer here. So we have ln x squared. These two x's are going to cancel, so we pretty much have plus 2 ln of x. And at that point, we could say, okay, we have a positive number here because we squared it. N is greater than 2, so this is going to be positive times a positive. We're squaring it and it's sticking it underneath the 1, so that's going to be positive. So this piece here is positive. ln of x squared is positive. 2 ln of x. Again, as long as x is greater than or equal to 2, all of this is going to be positive, so this is a positive. So we have -1 times a bunch of positive numbers. This is going to be negative. This is a decreasing function. Okay. And yes, you have to take the derivative, but you can go ahead and hand wave your way through that. That's not a problem. Okay, just show me the derivative. Okay, so we have all three conditions checked off for, can we use the integral test? We sure can. So now we have 1 over, I'm going to change this to the integral of 2 off to infinity of 1 over x ln of x squared dx. And of course, the first thing I'm going to do is change this to a limit as m goes to infinity, or I'm sorry, as x goes off to infinity, and say m is equal to this thing. So we have 2 up to m of 1 over x ln x squared dx. Okay, so that's what we're dealing with now. Okay, so again, we're going to say set u equal to ln of x, du is equal to 1 over x, okay, dx, and we'll go ahead and figure out what we need here. So we have, let's go ahead and change this. So we have x equals 2 to x equals m. M is equal to the limit as x goes off to infinity. And here we have 1 over u squared. Okay, so I'm going to say that's u to the -2. And then this 1 over x dx, this whole piece here, this is all of my du. Okay, so here we have a du. This isn't too bad of an integral. This is, -1 over u, right? It's with -u to the -1. Okay, and we're going from 2 to m, limit as M equals x goes off to infinity. Okay. So we can go ahead and plug that in. I'm going to do one more thing. I'm going to say this is equal to 1 over u, going from m to 2. See, I eat the negative sign by swapping the limits of integration. Okay, and we have our limit as x goes off to infinity, which is equal to m. Okay, so here we have 1 over 2, okay, 1 over 2 minus 1 over m, and we're looking at the limit as t as x goes off to infinity. This is what m is equal to. So we can go ahead and figure out what's happening with this thing. So this is going to be 1/2 minus, the limit as m goes off to infinity is 0. So we end up with 1/2. So since the indefinite interval, the improper interval converges to something, the series converges to something. So this series converges to a half. Okay? So series converges 1/2 by integral test. Okay? And that would be my answer to this problem here. Okay. I'm going to say thank you very much for watching my video. We'll see you in the next one and take care until then.